Okay, good. Okay, so every class is recorded. If I forget, once in 5-6 classes, I have the tendency of forgetting. Please, someone please remind me. And it's helpful not just for you. It's equally, it's more for the absentees. On any given day, someone is going to have something or the other. You're going to miss class, perfectly fine. But do catch up on the video sooner than later. Don't keep it for, again, till the beginning of the next class. Also, even if you attended the class, when you go through the video, things will stick in a lot better. Whenever you go through it a second time, obviously you don't have to go at the same speed. You can play it at 1.5 or 2 speed, or you can just fast forward to the specific locations where you didn't fully understand. So I urge you to use this facility that we have right now that everything is recorded. I'll send out the recording by the end of the week, in this case by Sunday night or max by Monday. Again, if I forget to send, one of you please put a message on the group to share the recording. So I'll do that. Okay, so we started off by saying it's mainly 3 topics: algebra, geometry, and the third is your statistics and probability. Okay, statistics and probability. And when I say probability, okay, so along with probability, it's also permutation and combination are included in this. So some of you might have heard of this permutation. It's nothing but arranging, right? Arranging game. So for example, let's say there are 5 students. They have to sit in a chair. There are like 5 spots labeled 1, 2, 3, 4, 5. Then how many ways can they sit? That sort of a problem is called permutation or arranging. And then there's combination. Combination is choosing. Choosing. So what do I mean by choosing? So let's say we are talking about cricket here, right? We have a squad. The cricket squad has 16 players, let's say. But not everyone gets to play the actual game itself. Finally, on the game day, they'll have to select a team of 11 players. Okay, so which 11 will be playing? So there's no concept of ordering. All of them are going to play. These 11 are going to play. There's no concept of arranging within that 11. I'm hoping around 11 dots or something. Okay, so which are the playing 11? So from the 16, so these 5 people or the unlucky ones are going to sit out. So this is the ground. Okay, so these are the ones going to play. So how do I choose 11 from the 16? So that's typically denoted as 16 choose 11. Okay, again, we'll get to all the details, but just so that, I mean, algebra, geometry, everyone understands. Permutation, combination is probably new to you guys, right? So which is why I'm just expanding a little bit on it. So from 16, how do you choose 11? In how many different ways can you form groupings of 11, right? And it turns out it's a fairly big number, right? If you think about it, it's a fairly big number. But how to quantify and how to exactly get that number, right? That's what we learn about in combinations. Okay, and probability is, if you know permutation combination well, probability becomes so much easier, because what is probability? Your favorable cases up to the total number of cases, right? You want a certain feature of all the possible features, right? So it's more like doing 2 different problems in permutation combination. You have a numerator and you have a denominator. Both of them, if you solve, then that's your probability. Of course, I'm simplifying it. There are a few complications as well, but for the most part, if you get this, then you're done with probability. And then statistics, you would have studied mean, median, mode. Again, all of this will go through from the basics. I'm not going to assume that you've covered everything, because people might be from different schools. You might have done some competition. Some of you might not. This might be your first one. So I'll definitely, for completeness, cover from the basics. But that said, I expect you guys also to put effort and catch up quickly. I'll be going at a brisk pace, because it's competitive math after all. It's not school math where we can afford to spend a lot of time on very, very basic stuff. So we'll be going at a brisk pace. You have to keep up, but we'll go from the basics. Okay. All right. So I think, in general, from my experience, all of you are reasonably good with algebra. I mean, when I say my experience, I mean, in the past batches I've seen, people are generally okay with algebra. Geometry is where a bit of struggle is. I mean, these days, compared to our times, your parents' times, and you guys, the geometry definitely has diluted over time. And on the other hand, algebra definitely has cranked up. So there's a lot of algebra, which is very heartening to note, being studied even at a lower level. but geometry definitely has diminished. Geometry, trigonometry, all of this have taken a, even calculus, I would say, has taken a hit. So we'll start with geometry. But I'll just pause here for a second. I want it to be as informal as possible. You should be like, you should do masti, but you should also learn properly, right? I don't want you guys to sit very tight, and I don't want to give a very strict type of thing, right? So be casual, but be, I don't know how to say it, right? Make the best use of the time and just enjoy yourself. Feel free to stop anytime with any question. I'm going to randomly ask now. Sana, all okay? Everything okay? Cool. Ashi, you have something to share? All good. Okay. Jan? Cool. Shurab, you're okay? Okay. Nice. So geometry, let's start with, we have triangles, and then we have quadrilaterals, and then extending it, we have bigger polygons. A polygon is nothing but, you have straight lines forming a closed figure. That's a polygon. So for example, this is a polygon. This is a polygon. I've intentionally drawn it like this. Okay, so maybe this part was a little unclear. Okay, I've intentionally drawn it like this, where an angle here is shown to be more than 180. That's also perfectly fine. What is an angle which is more than 180 called? Akshaj, do you know an angle which is more than 180 has a name?
Reflex angle.
Reflex angle, yes. So you can have a reflex angle like this. Acute, obtuse, right? All of you know. You can have a reflex angle. So this is called a non-convex polygon. It's called a non-convex polygon, where you have, if one angle is more than 180, it's called a non-convex polygon, as opposed to a convex polygon would be something like this, like typically the ones that we study. It's a quadrilateral, which is also a polygon. Depending on the number of sides, a polygon has different names, right? So triangle is 3-sided. Quadrilateral is 4-sided. These are the common ones. We have pentagon, right? So let's list it out. So pentagon for 5. Sure. What is a 6-sided polygon called?
Hexagon.
Hexagon. Okay. Rachit, 7-sided.
Septagon.
Yeah. Heptagon, septagon. I've seen both. Heptagon, septagon. Some people call septagon. Okay. Neve, 8-sided.
Octagon.
Octagon. Yeah, that's Snigdha answering on your behalf. It's good. Octagon. Snigdha, why is your video not on? Or you're not traveling, right? I heard
No,
from.
my video is on.
No, I don't see you. Do you guys see Snigdha? I see everyone else but you. And of course, Sukrit, for whom his dad requested, he'll be running late a bit. Snigdha, I don't see. Saurabh, can you confirm? Are you able to see Snigdha? No, right? Yeah. I might lie, but so Saurabh does not lie. So definitely Snigdha, you're invisible. So anyway, turn it on whenever you can. Octagon is 8-sided. Ashi, 9-sided is called what? Nonagon. Nonagon. And then 10, Sana?
Decagon.
Decagon. Is there a name for 11? I don't know. Jan, is there a name for 11-sided?
Sir, I think yes, but I'm not sure what it's called.
Okay. What's 12-sided called?
So is it duodecagon?
Dodecagon. Yes, dodecagon. Okay. So these are the common ones. And of course, there's some names for even bigger sided, but we don't need to necessarily know that. So for a polygon, the main things you need to know is what is the sum of the internal angles and what is the sum of the external angles. Okay. Sukrit, are you able to talk, Sukrit, or are you still in the car?
I'm able to talk.
You're able to talk. Okay. What is the sum of all the internal angles in a polygon?
N minus 2 into 180.
Yeah. The sum of all the internal angles in a polygon is n minus 2 times 180. Okay. Where do we get that from, Sukrit?
Sir, should I rejoin the meeting? Or...
Which one? Yeah. You want to join back from your other device? You can do that. Okay. So meanwhile, I'll just pass it on to someone else. I don't know. Do you know where the sum of all the internal angles adds up to 180 times n minus 2? For
I don't know why.
Okay. Does anyone know why? Anyone wants to share? You can raise your electronic finger or. Neve, do you know why it's adds up to 180 minus n 180 times n minus 2? You don't have to give a formal proof. Even roughly is fine. Okay, let's draw a picture, right? So let's say this is okay. I'm not drawing it like a regular hexagon. This is how much? 1, 2, 3, 4, 5, 6. It's a hexagon, but not a regular hexagon. So what does a regular polygon mean, by the way? A regular polygon means all the sides and all the angles must match. That's what a regular polygon is. So this is an irregular polygon. Irregular hexagon. Okay, so I say all the sides and angles must match, because only in the case of triangle, both are same in the sense an equilateral and equiangular triangle are both same. You have a 60, 60, 60, it's called equilateral as well as equiangular. Whereas if you go for anything more than 3 sides, these are 2 different things. Having same sides, having sides of same length need not imply angles are also same. Okay, Rachit, can you give can you give me an example of an equilateral quadrilateral that's not equiangular?
So where all sides are equal, but the angles are not, right?
Yeah, a quadrilateral like that. There's a
Rhombus.
rhombus, exactly. Okay, a rhombus is one where the sides are equal, but the angles are not equal. And what about the converse, Ashi? An equiangular quadrilateral, but not equilateral.
Parallelogram.
Parallelogram, are all the angles equal? Are they?
I don't think so. 2 are equal and 2 are.
Yeah, so that will not count as an equiangular, right?
Yeah.
Okay. So what would an equiangular quadrilateral be? That's not equilateral.
Rectangle.
Rectangle, yeah, correct. So rectangle would be equiangular, all of them 90, but not equilateral. Okay. So anyway, back to this question where we have why do we say we have the sum of all the internal angles is 180 times n minus 2. So let's say I have a hexagon here. Let's say I start with this as the base. Okay. So let's see how many, if I start dividing up into triangles, how many triangles can I divide into? So let's say this is my starting point A. Okay. Now my first triangle would be connecting the point 2 after that, right? So A, B, I cannot draw a triangle from A to A to B, then A to C. This will be my first triangle. Thereafterwards, I can join vertices and start forming triangles, right? So with each vertex that I'm connecting to, I have a new triangle. And that's it. I have to stop after I've reached the one before this, right? So how many triangles? We literally count. That's 1, 2, sorry. 1 was here. This is 2, this is 3, and this is 4. So it's 6 minus 2, which is 4 in this case. I've, of course, not proved it. I've just drawn an example to show that it's 6 minus 2. But you can easily extend this. I mean, a formal proof, you have to write a little bit, few more lines and just show that it's always n minus 2. But you can visualize, right? Start with one point. If the first triangle will start from the point after that. Keep completing till you reach the penultimate one. And you can easily count there are n minus 2 of them. If you have a 10-sided one, you will see 8 such triangles. And therefore, the sum of all internal angles is 180 times n minus 2. Because what is an internal angle? Oh, the internal angle is this is an internal angle. This is an internal angle. This is an internal angle, right? I've marked all of them with the same symbol, but it's not like they are all same. They're all different values. But if this angle at A, effectively, that will get counted as part of different triangles. But all of those contributions will add up to form A. Like that, every angle will get counted as part of some triangles. Totally, we'll get sum of all these internal angles as 180 times the number of triangles. Sorry, n minus 2 times the sum of angles in each triangle, which is 180. Okay. Now, if it happens to be an equiangular polygon, right? Or even a regular polygon. Regular polygon means it's both equilateral and equiangular. So regular would mean both equilateral and equiangular. So if it satisfies both, it's called regular. Sorry. I'm writing here. If it's both equilateral and equiangular, it's regular. So in a regular polygon or an equiangular polygon, what happens is we can talk about each internal angle. We can talk about each only when all of them are same, right? It's 180 times n minus 2 upon n in such a case. Okay. Each external angle, okay, we can also talk about each external angle in a regular polygon. But what about sum of all the external angles in a general polygon, which is not regular, let's say? So just like sum of internal angles was this, what is sum of external angles? Saurabh, do you know what is the sum of all the external angles?
360.
Yeah, 360. Yeah, if people can answer, whoever I called out, I'll make sure that everyone gets a chance. But please, if people can answer based on turns that I call out. Sometimes I might say anyone can answer, then you can unmute. Okay, so well done, Saurabh. So it's sum of all the external angles is 360. And of course, for a regular polygon, you can talk about each. With a regular or equiangular, then we can talk about each. Otherwise, you cannot talk about each. No, if it's not the same, how can you talk about each? So it's 360 by n. Okay, how do you arrive at 360 by n? Okay, so let's say a couple of ways. So let's say I'll just draw another polygon here. Okay, what is an external angle, by the way? An external angle, sometimes people think this is an external angle. No, that's wrong. That's not an external angle. What's an external angle is, I'll erase this first. I have to extend one of these sides. So let's say I extend this side. Okay, and whatever balance is left here, that is an external angle. This is an external angle. Okay, so similarly, here this becomes an external angle. This becomes an external angle. This becomes an external angle. This becomes external angle. So sum of all of these is 360. And why is that? So let's say you place your, let's say you have an arrow that's right now sitting here. And then with every vertex that you reach, you keep tilting, you keep tilting, keep tilting, keep tilting. And by the time you reach here and you do the final tilt, you're back to that same line, same straight line that you started off with. So which means you have covered one full circle of 360 degrees, which is why the sum of all the external angles is 360. Okay, so this will also give you a different way of proving why sum of all the internal angles is 180 times n minus 2. So sum of external angles is 360, we just saw. You start with an arrow, keep tilting, keep tilting, keep tilting. At the final vertex, you make the final tilt, and then back to the same line where you started, therefore 360. So let's start with that. So sum of external angles is 360. Okay. Now using this, we can also find sum of internal angles. How? Okay, so let's say we didn't know it's 180 times n minus 2. Let's say whatever that is. Now, what is the sum of both external and internal angle? If you look at that, at each vertex, the internal angle and external angle are adding up to 180. Here it's 180, here it's 180, here it's 180, and so on. And there are n such vertices, right? So the sum of both is 180 times n. Okay, and therefore this guy here, sum of internal angles, has to be the difference, which is 180n minus 360, which is back to 180 times n minus 2. Does it make sense? Another way to arrive at sum of internal angles being 180 times n minus 2. Okay, what about diagonals? So let's say I have, okay, again, let's stick with the hexagon. Doesn't matter. Okay. Again, I'm intentionally drawing it irregular so that we don't make any false assumptions. How many diagonals will this have, or an n-sided polygon? Neve, do you know how many diagonals will an n-sided polygon have? Number of diagonals.
Not really sure, sir.
Not sure. Okay, fine, no worries. Snigdha, do you know number of diagonals in an n-sided polygon?
I think it will be again n minus 2.
So please repeat again. Sorry.
Will it be n minus 2?
N minus 2. Okay. All right. That's a guess. But always when you guess something, you can always check, right? How many diagonals does a triangle have? Does triangle have any diagonal? No.
No.
Right? So if at all your formula is right, then it must be like one diagonal, right? So 3 minus 2 is 1. So you can always do some basic sanity check when you call out any formula. Okay, again, this is not to highlight your mistakes, Nigda, but this is to highlight a general point for everyone. always do some basic sanity check whenever you call out some answer. What do I mean by sanity check? At least some simple cases should validate. You should be able to validate, right? So if whatever formula you give, instead of n minus 2, suppose she said n minus 3. Okay. I would have sort of accepted it. Why? Because for a triangle, we have zero diagonals. But soon I'll find there's a mistake, right? Because if it's a quadrilateral, according to her formula, it should be one diagonal. But for a quadrilateral, I expect two diagonals, right? So the formula n minus 3 is also wrong. Okay. Does it make sense? That's what I mean by simple validation. Try for 2 or 3 basic things. For a pentagon, how many diagonals there are, guys? Does anyone know for a pentagon? Sana, do you know how many diagonals does a pentagon have? You can draw it yourself and check quickly.
0.
Pentagon, not a triangle.
5.
5. Yeah. So pentagon has 5. So that's, let's say this is the number of sides and this is the number of diagonals. So what is our observation so far? If it's 3-sided, we should expect 0 diagonals. If it's 4-sided, a quadrilateral, we expect 2 diagonals. If it's 5-sided, we expect 5 diagonals. Yeah. Right? 5 diagonals. You can draw and see. Does anyone, Sukrit, are you back online?
Yeah, but I'm still in the car.
Or still in the car? Okay. Do you know the formula for number of diagonal signals, Sukrit?
No.
Okay. Ashi, yeah, go ahead, please.
Is it 2n minus 3? That's what I'm getting, I think.
Please repeat again.
2n n minus 3.
2n n minus 3. Like this?
Yeah.
Okay. Does it work? Let's check. If you put n equal to 3, it works. 2 times 0 is anyway 0. If you put n equal to 4, does it work? 2 into 4 into 1 is 8 diagonals, no? If you check for n equal to 4, it's giving 8. But you're very close. It's
So
n and yes. Go ahead, Saurabh.
So if you do n plus 1, will it work in the brackets?
Say that again.
2n n plus 1.
2n n plus 1, like this.
Yeah.
Okay. Let's check again. For a triangle itself, it does not work. No, if you put n equal to 3, I should get 0. I'm not getting 0. Yeah, that's fine. Okay, I got you guys thinking. That's the main thing. The formula is n into n minus 3 divided by 2. Okay, and we'll derive it quickly, right? No problem. But let's quickly check if it validates. If I put n equal to 3, I get 0 in the numerator, right? 3 minus 3 is 0, so we're okay. If you put n equal to 4, what do I get? I get 4. The formula says 4 into 1 by 2, which indeed matches with 2. If you put 5, I get 5 into 2 by 2, which is indeed 5. And we can try for like one more maybe for hexagon. Let's try to draw all the diagonals in a hexagon. Let me just draw a small hexagon. Okay, so let's draw the 1, 2, 3. Okay, 4, 5, 6, and then it's too small. Maybe I should have drawn it slightly bigger. Starting from here, right? So 7, 8, and then there is 9 here. Okay, so those are the 9 diagonals. Sorry, it's very, very small. I should have probably drawn bigger. I knew the answer was 9, so which is why I was going to be okay. So this is 9, which is 6 into 6 minus 3 is 3. So 6 into 3 by 2 indeed gives 9 as well. So the number of diagonals is n into n minus 3 by 2. But how do we arrive at this? Knowing this formula, can someone, and seeing how I drew, can someone be able to, can someone explain how I get n into n minus 3 by 2? I'll give you guys 30 seconds to think about it. Rachit, can I try with you? Any idea why it's n into n minus 3 by 2?
No, sir, I don't know.
Okay. I'll give you guys another 10 seconds, 15 seconds to think. Neve? Okay, so what am I doing? How do I, let's go through the process of drawing a diagonal in this picture at the bottom. It's much bigger, right? So it's easier. Okay, A, B, C, D, E, F. Okay, again, does not have to be hexagon. I'm starting off with some example. Okay, I'll start with some vertex A. Okay, so from vertex A, Akshaj, just from vertex A, how many diagonals can I draw?
3.
3. Okay, namely, I'll
A-
just draw this. Yeah, AC, AD, and
AE.
AE. Correct. So I'll just draw all of them. Okay, and Akshaj, why do you think I was able to draw exactly 3 diagonals? I mean, explain the process why it was 3 or not 4 or not 2, for example.
I draw AB, it's already a part of the
Very good.
shape.
Very good.
And AF is part of the shape.
Very good. And
So,
you can
so
you cannot draw a diagonal from A to itself,
yeah.
right? So very good. Yes. So there are n vertices. When I say n-sided polygon, it obviously has n vertices as well. So when 6-sided polygon has 6 vertices, A, B, C, D, E, F. Okay. Now what he's saying is I cannot draw a diagonal from A to B because that's the adjacent one. So B is ruled out. So I'll start marking what is ruled out. I cannot draw a diagonal from A to B. I cannot draw a diagonal from A to F. So the 2 neighbors are ruled out, and you rule out yourself. I cannot draw a diagonal from A to A itself. Okay. So that leaves a balance of n minus 3. Okay, in this case, both are 3. It's a little confusing, but let's say it's a 10-sided polygon and A is the first vertex in it or some vertex in it. From A, I cannot draw to my right neighbor, my left neighbor. I cannot draw one to myself. So I subtract 3 and say I can draw 7 diagonals from myself. So n minus 3. Okay, so that's the first n minus 3. And then, Saurabh, can you take it forward from here? Why do I multiply this by n now? Can you explain the formula with this background? Now that you have concluded on n minus 3. You don't have to raise your hands, guys. Don't worry. I'll definitely give everyone a chance. Don't worry. Or no. Saurabh, give it a shot.
So you multiply it by n because of the number of sides there are, and you're subtracting it by 3.
Subtracting by 3 is already explained just now, right?
Yes.
You cannot draw a
Yes,
diagonal
yeah.
to the right, left, and you cannot draw one to yourself. So that's n minus 3.
Yeah,
Why am I
so-
multiplying by n?
Yes, so you're multiplying by n because each of the sides can have 3 more diagonals. So like E can have 3 more, D can have 3 more, and thus you have to multiply it by 3.
Exactly.
By
One small silly mistake in what you said. Each of the vertices has these n minus 3 diagonals, not each of the sides. From each, whatever you did for A, you can apply the same thing for B, same thing for C. So B has n minus 3 diagonals, C has n minus 3 diagonals, D has n minus 3 diagonals, and so on. So it's n minus 3 times n. Okay, Arnav, can you complete the last part? Why am I dividing by 2 finally then?
So I'm not really sure why we divide by 2. I understood why we multiply by n, but not
Okay,
really why we divide by 2.
all right. I'll pass it on to Ashi. Do you know why I divide by 2, Ashi?
Sorry. I just
Yeah,
understood.
go ahead, Arnav. Yeah.
No, because each of the vertices, they will have like they, supposing there's A and B. So in A's part, there will be A to B counted, but in B's part, there will be B to A counted. So then you'll get doubles. Thus, you have to divide it by 2.
Very good. Except that you did not have to use the word B because A to B, there is no diagonal at all. A to D or A to E would have been a good example. But conceptually, you're right. Basically, he's saying that's double counting because if I look at the diagonal AD, I'll mark it here, right? This one, AD. A is also counting in his quota. D is also counting in her quota. Let's say I'm assigning some gender to A and D just to differentiate, right? But a diagonal is only one diagonal. I cannot count it twice. And therefore, to compensate for the double counting, I divide by 2. Okay. So always try to intuit out how these formulas come, right? That way, it'll stick with you forever, right? Or even if you forget, you'll be able to derive it from basics. So now, after this exercise, even if you forget day after tomorrow what the number of diagonals is, you can quickly go through the thought process. How did I derive? I saw each vertex. From each vertex, I can draw n minus 3 because I cannot draw to myself, to my right neighbor, to my left neighbor. Therefore, it's n minus 3. Apply the same logic for everyone. Therefore, it's n times n minus 3. Double counting. Therefore, divide by 2. Right? Everything speaks for itself. Does it make sense, guys? Okay. All right. Cool. Okay. So that's polygon. Now let's start a little bit more on some of the 2 basic polygons. So triangles and quadrilaterals are very important. So again, basic stuff only. You guys already know, but I just want to give it some structure. So you can classify triangles as equilateral or isosceles or scalene. on one hand. Okay. On the other hand, you can also classify them as acute, right, and obtuse. So acute, right, and obtuse is based on angles, right? So this is based on angles. Okay, and this is based on sides. Okay, but there's obviously overlap. So what do I mean by that? Can I have an equilateral triangle that's acute? Yes. In fact, an equilateral triangle is always 60, 60, 60. Therefore, there's only one equilateral triangle possible, which is 60, 60, 60. It always has to be acute. So can I have an equilateral? Can I have an acute angled isosceles triangle? Can you give me an example, Akshaj, of a, I'm here right now, acute isosceles triangle? Give me in terms of sides or in terms of angles, doesn't matter.
Maybe 70, 70, 40.
70, 70, 40. Very good. Okay, so he's saying 70, 70, 40. He'll have two steep angles like 70 each, and then he'll have 40 here. Okay, that's isosceles and scalene. Isosceles and acute. Rachit, quick one for scalene. Scalene acute. An example. Rachit.
Yes, sir.
A scalene acute angle triangle.
You can have like 60, 50, 70.
50, 60, 70. He took 60, 60, 60, and then deviated by 10 on either side. He made one of them less by 10, and he made one of them bigger by 10. So 70, 60, 50 is a perfect one. Okay. So a right angle equilateral triangle. Give me an example.
Yes. Sir.
Right angle equilateral
So
triangle.
right angle. So 90, 40.
Say that again. 90.
So 90, 45, 45, but it won't be an equilateral.
Okay. But how can I draw a right angle equilateral triangle? It's meaningless, not possible at all, right? Some of them are.
You can't.
Yeah, that's exactly what I wanted you to say. You should have given me a dirty look and say, what nonsense are you talking about? Okay, but you are very kind. So it's not possible. Yes. So similarly, an equilateral obtuse is also not possible, right? In equilateral means it's 60, 60, 60. So it's no way it's right or obtuse. And you sort of already answered this question for me. So it's 90, 45, 45 becomes an isosceles right angle triangle, which is very important. Study a lot on this, not a lot of the questions are based on 45, 45, 90 based triangles. Okay, so this is isosceles as well as it's equilateral. Isosceles as well as right. Quick example on scalene right angle triangle.
90, 50, 30.
90, 60, 30. Yeah, that's another popular one. 90, 70, 20, 90, 60, 30, doesn't matter as long as you pick two complement angles. So this is 90, 60, 30. Okay, by the way, 30, 60, 90 also has some interesting properties, which very popular in AMCs. So we'll cover that as well. Okay, isosceles obtuse, Sana. Isosceles obtuse, give me an example.
140, 40.
140, 40. So you make the two smaller angles add up to less than 90, so that the remaining can be taken up by an obtuse angle, which is 100. Okay, and last one, who wants to complete this one? Akshaj, scalene obtuse triangle.
30, 40, 120.
30, 40, 120 do not add up to 180 though. But yes, you're right. 30, 40, and the balance, which is 110, right? So something like this. So this is 110, and this is 30, let's say, and this is 40, let's say. Okay. Anyway, you guys all get the idea, right? So some are possible, some are not possible, and some are important. So let's study the important ones a little bit more. So in a 45, 45, 90, so 45, 45, so I'll just do this one. Okay. In a 45, 45, 90, the ratio of the side lengths. Okay, I didn't draw it parallel to the base of the page, but that's fine. Okay. So this side and this side are equal, which is why it's isosceles. Sukrit, are you there? Is Sukrit back?
Yeah.
Okay. So Sukrit, do you know what the ratio of the three side lengths is in an isosceles right angle triangle like this, like the one I have drawn, ABC?
It's
2:1:1.
2:1:1. So basically he's saying this is 1 unit and this is 1 unit and this is 2 units. Arnav, do you agree or disagree with him?
Sorry, sir.
Do you agree or disagree with him?
One
Or
second.
you don't have a view?
I really don't have a view. I'm still trying to like.
Okay, anyone else has a view on this? Ashi, what about you?
So it doesn't necessarily have to be 1:1, right?
It has to be
Particularly
one.
A, B, and BC.
It has to be 1:1 for
It
sure
has to.
because it's isosceles.
Okay, I saw. Okay, sorry.
The only
I
question is, yeah, go ahead, Sukrit.
I thought you were talking about angles. I didn't
No,
know
no, no.
about sides.
Okay. Angles, of course, it's 1:1:2. This is 45, this is 45, and this is 90. Angle ratio is 1:1:2. That's for sure. I was asking about the side ratio. So is the Sukrit, you want to still stick with 2, or you want to change your answer, or what do you think?
I want to change it. It's
To what?
1:1 square root of 1 squared plus 1 squared.
Which is square root of 2. Correct. Okay. So just by Pythagoras theorem, let's say this is 1 unit and this is 1 unit, A, B, and B, C. Then by Pythagoras theorem, it just becomes 1 plus 1, which is square root of 2. Okay. In fact, yeah, all of you okay on this one, right? 1:1:2. Yeah. Saurabh, you're okay? The ratio of the side lengths, 1:1:2. Now back to what he said earlier. He said 1:1:2, of course, thinking it was angles, but anyway. But suppose someone says the ratio of side lengths in some triangle is 1:1:2. I'm not saying it's a right angle triangle. Is it possible to have some other triangle where the ratio is 1:1:2? Sana, what do you think? Is there any other triangle possible where the ratio of the side lengths is 1:1:2? Does not have to be right.
It could be a scalene triangle.
It's definitely not scalene because 2 sides are equal, right?
Yeah.
Right. It's definitely isosceles, but I'm saying need not be right angle. In isosceles right angle, we saw the ratio is 1:1:2, as we just saw here. But maybe it could be an isosceles obtuse angle triangle where this is 1 and this is 1 and this is 2. That's possible, right?
Yeah.
Okay. No, that's not possible. I was prompting you to say yes, but no, that's not possible. Why is that not possible?
Because two sides of a triangle always have to be, the sum of the two sides of a triangle always have to be greater than the length of the third side.
Excellent, Snigdha. Yes. So one basic property of a triangle is sum of 2 sides must always exceed the third side. And Snigdha, can you expand on it a little bit? Why is it that? Why does that property have to be true? Why is it that sum of 2 sides has to exceed the third side? It should not be even equal. It should exceed. Why is that?
I'm not sure.
You're not sure. Is anyone else sure? Can you guys think about why do you think that is the case? Rachit, any idea? Who am I missing in class today? Someone is missing. Oh, no, actually, I do have everyone. Okay, yeah. Go ahead. Sorry, someone was opening their mouth.
Yeah, so
Sukrit, go ahead.
if the sum of 2 sides was equal to the third side, then it would just be a straight line.
Exactly. And if it's less than the third side, then?
Then it won't go till the end of the third side. It'll only.
Excellent. Yes.
Yeah.
So what he's saying is, let's visualize in terms of some stick lengths. Okay, let's say, forget this 1:1:2 example. Let's say I have I have 3 sticks, one of length 3 units, another stick of length 4 units, another stick of length 8 units, right? There are 3 sticks. There's a small stick, there's a medium stick, and there's a large stick, right? If I try to form a triangle using this, so let's say I place the large stick here. This is 8 units long. Okay. Now the small stick, which is in red color, okay, I try to place it here. Okay. This is 3 units. And the medium stick of length 4, okay, maybe the 3 was slightly bigger than this. So 3 was till here, let's say. Okay. And the medium stick is 4 units. Let's use this color. Okay. So this is 4 units. Okay. Now, obviously, it's not forming a triangle. For me to force it to become a triangle, I'll just bring it down as much as possible. But he's saying even then there'll be a gap of 1 here because the total length is 8. And even if the total length is not 8, but let's say it's 7, it'll just about collapse exactly. It'll form a straight triangle, or it's not even a triangle. We can think of a fake triangle where the top angle is 180 degrees and the bottom two angles are 0 degrees and 0 degrees. So it's an extreme end of a triangle, which is not really a triangle, but a straight line. So it's not a triangle in a sense. So for something to form a triangle, we need that sum of two sides must exceed the third side. Again, we don't have to be integers. One side can be 3.2, another one can be 4.5. So what is the sum of these two? 7.7, right? I can have the third side 7.697, right? Doesn't matter. As long as it's less than 7.7, I'll be able to draw a triangle. It might be very, very obtuse. The top angle might be 179.99 degrees, but it'll still be a triangle. Okay. So basic funda, sum of two sides in a triangle will obviously should add up to bigger than the third side. Should add up to more than the third side. And always it's best to talk in terms of the smaller two sides exceeding the larger side. Otherwise, it's not even a comparison, right? If you're taking the larger side and adding with something more, obviously it'll be bigger than the third side that's left. So the real competition is between the small and the medium, adding up to bigger than the large one. Okay. All right. Now, a simple note on how to name triangles. So if I have a triangle, ABC, let's say, the normal convention is whatever is capital letter, or capital letter is used for vertices, small letters are used for sides. So small letter, I can call this M, for example, I can call this A, I can call this X, for example, but it's not going to help anyone, right? So typically, to help easily associate angles and sides, the smaller letter, the corresponding smaller letter is used against the corresponding capital letter. So opposite to capital A, you have small a as this side, small b as this side, and small c as this side. So always use them in pairs, capital and small, just opposite. That way, it becomes, problem solving becomes a lot easier and symmetric. Okay, but always use capital letters for vertices and small letters for sides. Unfortunately, many of the teachers also in school, I would say, are not following this convention. So it's unfortunate. Textbooks definitely follow this convention if you look at it. Okay, so stick with that. Now, the other important triangle I said was the 30, 60, 90. Right? So someone gave that example. Was it Neve or someone? Right? 30, 60, 90 is also another scalene triangle, just like 20, 70, 90. But 30, 60, 90 has special importance. So what importance? So let's take another page now. Okay, so let me draw a 30, 60, 90 here. And I'll ask the same question. In a 30, 60, 90, what is the ratio of the side lengths? Not the angle lengths. The angle lengths are 1:2:3, because 30, 60. Not able to draw a line which is vertical. This irritates me. I don't know why. Okay. All right. This is a vertical line. This is better. Okay. So this is now 30. This is 60. And this is 90. Okay. So same question as before. What is the ratio of the side lengths? So let's call them. So this is small a. This is small b is the hypotenuse here. Small c is the smallest side here. Okay. So first of all, sides will be in the same ascending order as the angles, right? So which means the one opposite to 30 degree will be the smallest side. The one opposite to 60 will be the medium one. The one opposite to 90 will be the largest side. But ordering is one thing. So in this case, what did we say? Capital C was the smallest angle. Capital A was the next one, sorry. And capital B was the biggest angle. So accordingly, the sides also will follow this order. But the ratios need not be same. In this case, the ratio is 1:2:3, right? 30 degree, 60 degree, 90 degree. But the ratio of the sides will not follow that same order. In fact, it cannot, as we just saw. 1 + 2 adds up to 3. How can we form a triangle of where two sides are adding up to 3, as we just saw? Not possible. What is the ratio now? Does anyone know the ratio of the sides in a 30, 60, 90 triangle?
It's 1:2 √5.
No, but you were close. Okay, so you're saying, okay, so basically he was saying this is 1 unit, and this is 2 units, and this is √5 units. At least it's a Pythagorean, it follows the Pythagorean thing, right? It's 1 square plus 2 square is √5 square. That's why he called √5. But C:(A) is not 1:2, Sukrit. Okay. But 1, 2, root 5 is a Pythagorean triplet. That I agree. Okay, so this is not 1 is to root 2 is to root 5. Let's start with 1. Let's say the smallest one is 1. So how much is A and how much is B? Let's say C is 1. Does anyone know? Okay, all right. It's 1 is to root 3 is to 2. Okay, first let's check 1 square plus root 3 square. What does it add up to? 1 plus 3, which is 4, which is 2 square. So 1 square plus root 3 square is 2 square. Okay, but where are we getting this from? Let's say this is 1 and this is root 3 and this is 2. We have to prove it, right? So let's prove it. Okay, again, proofs are all not there for AMCs, but I want you guys to understand the concepts. All of this, right? Concept building will help solve problems. Okay, so let's prove. I'm not going to mark them as root 3 and 2 for now. I'll just call it 1. I'll just start with something as 1. It's all ratios, right? I can start with something and call it 1 and then build up everything based on that. Okay, so let me draw a reflection around BC. Okay, I'll draw a triangle to the bottom, which will be a reflection of this triangle. So, okay, so I've drawn this. So let's call this D. Okay, now because it's a reflection, this length will also be 1 because it's a reflection, pure reflection. Now this big triangle, so because this is 60 degree, by reflection this will also be 60 degree, and this is 30, this is also 30. Now this big triangle ACD, you can clearly see is equilateral, right? 60, 60, 60. So all the 3 sides have to be equal, which means we know AD is 1 plus 1, which is 2, which means AC should also be 2, and this should also be 2. Okay, so all the 3 sides of the big equilateral triangle are 2 each. So we have already arrived at 1, we have already arrived at 2. Then the only missing piece is to find A, and that we can do by Pythagoras theorem. We know once, if I take the top green triangle, I'll say C square plus A square equal to B square. So I know C and I know B. I can complete A therefore. Therefore, A square is 4 minus 1, which is 3, and therefore A is root 3. Does it make sense, guys? Just 1 second. Just 1 second. Okay, does it make sense, guys? So 1 is to root 3 is to 2. Okay, so this comes in handy in many problems. So you can, for example, let's say I'll just give a small problem. Okay, you guys can try it. Now I'll say this is an equilateral triangle. Okay, I'll use my straight liner, otherwise it becomes difficult. Okay, so this, in this diagram, I'm saying this is 90, this is 90. I've marked these 2 sides as equal, and this is 30 degree. Okay, and I'm saying this is 3 units. I'll mark all of them with, let me use some other letters, P, Q, R, S. Can you find RS? Find the length of RS. I'll give you guys 1 minute to work on this. Okay, all of you will do. I want Arnav to call out the answer on this one.
So 1 second, I'm just solving.
Okay, okay. Yeah, all of you are solving, I know. Okay, another 20 seconds, guys. Okay, that's it. Okay, time's up. Arnav, you want to take it or should I pass it on to someone else?
So I'm not really sure about my answers. If you could pass it on.
Okay, I'll give it to, let's say, Neve. Neve,
So
tell
I'm
me.
still solving it.
Okay. Does anyone have an answer? You can lift your hand, electronic hand, or your physical hand. That's fine too. Sukrit, do you have an answer?
I'm still solving it.
Okay. Jan, how about you?
Sir, even I'm still solving.
Okay, Ashi's hand is up. Go ahead, Ashi.
Me?
Yes, Ashi.
Yes. You know,
I cannot hear you too well. Your voice is little muffled. Please try again. What did you say?
I asked if the answer was 3.
3. Okay.
Yeah.
Doesn't it look bigger than 3?
Oh.
I've drawn it reasonably to scale. It looks bigger than 3, no?
Yeah. Okay.
Okay. Okay, Sana, go ahead.
I don't have an answer, but to solve it, PR would be 4.5, root of 4.5.
Why would PR would be root of 4.5? Okay, why so?
Because using Pythagoras' theorem, you know, PQ is the hypotenuse. So it would be divided by 2, and because it's an isosceles
Very good. Very good.
triangle.
Yes, yes.
Then using the method of the reflection, you can find out that if you name the point that you create in the in like extending the triangle of PRS, you can, if you name it say T, then R to T would be root 9.5.
You mean extended upwards this way?
Yeah.
Okay. You mean, okay, like this, right?
Yeah, it would be that times 2.
Mhm.
So then you could say that the other 2 angles are it's an equilateral triangle because it's a similar triangle to ABC, and so that means that all of the angles should be root 4.5 multiplied by 2.
All of the sides must be root 4.5 multiplied by 2.
Yeah.
Excellent. Okay, but just once, okay, all right, I'll explain again for everyone. You could have done it shorter, but you did it from basics, which is nice. Okay, all right. I'll erase. This is what 2 times root of 4.5 was your final answer, right, Sana?
Yeah.
Correct. Okay, so I'll erase this. Now, even though I showed the reflection and all, you don't, for every single problem, we don't have to go to the basics and derive it. You can use some standard results. We have already derived the ratio of side lengths in a 30, 60, 90 is 1 is to root 3 is to 2. We can use that. Similarly, for a 45, 45, 90, we saw the ratio is 1 is to 1 is to root 2. We can use it. You don't have to go every time reinventing the wheel. By that, what do I mean? Okay, so just a quick recap again for everyone. So in a 45, 45, 90 triangle, the side lengths follow the ratio 1 is to 1 is to root 2. Okay, that's point number 1. Point number 2, in a 30, 60, 90, 30, 60, 90, the side lengths follow the ratio 1 is to root 3 is to 2. I want these to be used, right, rather than reinvented every single time. Yes, you should know how we derive it, but we shouldn't waste time deriving it every single time, right? So we are only going to use it now in this case. So let's focus on the triangle PRQ. So PRQ, Saurabh, do you agree PRQ is an isosceles right angle triangle? It's a 45, 45, 90. Do you agree? Saurabh?
PRQ.
PRQ, isosceles and right angle. So which means it's 45, 45, 90.
No, sir.
Why?
No, sir. It has to be scalene.
Why scalene? I have marked it to be isosceles. I'm not tricking you. So this is 45 and this is 45, right? It has to be, right?
Oh, yeah, yeah.
Yeah. Okay. So we can apply the ratios 1:1 is to √2. But so which means what PR is to RQ is to PQ is 1:1 is to √2. Okay. So which means, in other words, PR by RQ, sorry, PR. Okay. So PR by RQ, sorry, PR by PQ is 1 by √2. Okay. PR by PQ. This is P here. Top one is P. Let me just erase it and rewrite it so that it's clear. This is P. Okay, so PR by PQ is 1:2, but we already know that PQ is given to be 3 units. Therefore, we can find this easily. So just by cross multiplying. So X into √2 is 3, which means X is 3 upon √2. Okay, now Sana said it's 4.5, but both are same. So how are both same? If I simplify 3 by √2, okay, we generally don't leave roots in the denominator. To avoid that, you multiply and divide by something to compensate for the root in the denominator. In this case, multiply and divide by √2 so that I get 2 in the denominator. I get 3 √2 in the top. Okay, so what she said was root of 4.5. What is root of 4.5? That's root of 9 by 2, which is same as 3 by √2. So it's effectively same as what we had. I just multiplied and divide by √2 so that I don't have root in the denominator. So it's 3 √2 by 2. Are you guys all with me so far? Akshaj, are you with me? Why this is 3 √2 by 2? Okay, good. 3 √2 by 2. Okay, or 3 by √2. Both are same. Now I'll use that in the second triangle because the common connection between PQ, which was given, and RS, which was asked. So let's not forget the question. The final question is find RS. The common connection is the line which is PR. So now we have found PR. Let's use it in the next triangle. In the next triangle, what do we know? It's a 30-60-90 triangle. So it's a 30-60-90 triangle. We know the ratio of the sides is 1:√3:2, as we just saw. So which is the smallest one? The smallest one is the one opposite to 30 degree. So that is 3 √2 upon 2. Okay, so I don't care about this one, the middle one. I care about the longest one. This one I care about. So that should be 2 parts, which means it should be twice of 3 √2 by 2, which is just 3 √2. Does this make sense, guys? Akshaj, are you with me completely? All of you, I'm just calling Akshaj, but Snigdha, you're okay? Yeah?
Yes.
Neve? Saurabh? Okay, cool. Jan, you're okay? Cool. Now let's talk about, this is, so one Pythagorean triplet, which is 1:1:√2, as we just saw. And another Pythagorean triplet, this is in a 45-45-90 triangle. 1:√3:2 was a 30-60-90 triangle. Okay, but these are technically not triplets per se, because when we say Pythagorean triplets, we mean integers. So let's talk about Pythagorean triplets. Pythagorean triplets. Okay, so the triplets that you would have normally studied would be things like 3:4:3, 4, 5 is a right angle triangle. You guys would have commonly encountered it, right? So 3, 4, 5 is a very common right angle triangle. 3 square plus 4 square is 5 square. We all know that 9 plus 16 is 25. Okay, but there are other triplets also. Okay, Rachit, can you tell me another triplet like 3, 4, 5?
6, 8, 10.
Okay, 6, 8, 10, but I won't allow 6, 8, 10 because if you simplify 6, 8, 10, there's a common factor of 2. It reduces to 3, 4, 5.
Oh.
Right. So can you tell me something which even after reduction, the final state, it's something different from 3, 4, 5? Okay, Akshaj, go ahead.
12, 5, 13.
Yeah, 5, 12, 13. Yeah, okay. I try to go in ascending order. 5, 12, 13. That's a good one. Yeah, Neve, another one. Neve, another triplet.
I'm not sure.
Okay, Arnab, yeah, go ahead. Arnab, your hand was raised, right? Sorry?
1, 2, 3.
1, 2, 3. We discussed, right? 1, 2, 3 cannot be even a triangle. Forget a Pythagorean triplet. 1 plus 2 adds up to 3. We must need the sum of two sides should exceed the third side, right, Arnab?
Sorry, sir. I got confused. Sorry, sir.
Yeah. I saw someone else's hand also going up. Who was that? Sorry. Ashi? No, before Ashi, I saw someone else. Was it Akshat said 5, 12, 13. And then I saw two hands go up. Jan, yeah. Jan, you had a triplet, yes.
So I was going to say 5, 12, 13.
But unfortunately, that's taken, Jan. Okay, Ashi, good. Over to you.
24, 25.
Sorry?
7, 24, and 25.
Thank you. Thank you. 7, 24, and 25. And you already see a pattern here, right? You guys see a pattern here? Sukrit, what is the pattern so far? Either in each row or following along each column also, either way. What is your observation?
The it's so for the first one it's just plus 2, plus 2, plus 2,
Plus
and then
2,
for
plus
the
2, plus 2.
second one it is 4, I mean the middle number into the gap between the first number of the first one and the first number of the second one, which is 2. No. 4 into 3, which will give you 12.
Yeah.
But then 12 into 5 doesn't give you 24.
Exactly.
So,
okay.
but for the last number, it's into 2 plus 1.
Into 2 plus 1. Which into 2 plus 1?
No, wait, it actually doesn't work. Never mind.
Okay. Okay. So one observation was the first column is all odd numbers. Another simple observation was, I don't know why that I didn't see that coming yet. These are consecutive numbers, right? Sorry, I probably didn't ask anyone. That's why. Okay. These are consecutive numbers. Okay. I'll give you one more row. Or does anyone know a triplet? Just 1 second. Who was that? Gyan, was that you?
Yeah.
Okay. Yeah,
so 9, 40, and 41.
Exactly. I was going to complete this row. Now, does this pattern help? Jan, how did he find 9, 40, and 41?
So I just knew that triplet from sums I've done previously.
Sums you've done previously. Excellent. Yeah, that's how it should be, right? Pattern recognition from problems done previously. Now we have enough to see a pattern going on here. Okay, so can someone complete what the triplet will be when I start with 11? Okay, Gyan, go ahead.
So 60 and 61.
Excellent. Why is that? Why is that?
So it was 4 and then 12. So there's a difference of 8. Then 12 and 24, there's a difference of 12. So you add 4 every time. So 24 and 40 was 16. So I added 20 and then there was a consecutive number.
Excellent, right? So I'll come to that. Okay, so that's good for a start. So basically he's saying this difference is 8. This difference is 12. This difference is 16. Therefore, he's seeing the differences are going up by 4 every time. Therefore, the next one is 60. Well done there. Okay. But one problem, Jan, I wouldn't say problem. I would say, suppose going along this pattern, way down here, suppose I ask you next for 13, you will say it correctly. Because I don't have space here. Let me just start here. 13, then you'll follow the same. Anyone other than Jan can tell me, is it Jan or how do I pronounce your name, Jan?
So Gyan.
Gyan. Okay, good. Okay, can anyone other than Gyan tell what the next two numbers should be for 13?
13, 64, and 65.
Not 13, 64, and 65. What is he adding? What is he adding? Be careful.
It will be 1384.
And
Correct. 1384 and 85, right? He has to add 24 now. Therefore, it's 1384 and 85. Okay.
Oh, yeah,
But the problem is if I keep asking next 15, next 17, then you're okay. But suddenly if I jump to way down here, 41 is also an odd number. What should come here? Then unnecessarily you have to work out every number in between here, which is a pain, right? So instead, can you see a pattern in each row itself? For example, without worrying about what happened before or after, I'm just marking one particular row. Can you see a connection between 7, 24, and 25? Forgetting the rows above, forgetting the rows below, just these three numbers can you correlate? 24 and 25 are consecutive numbers, that's one thing. But any two numbers that were, yeah, Ashi, go ahead.
Into 1 plus 1, and then again increase by 1, then into 2 plus 2, then increase by 1, then into 3 plus 3, then increase by 1.
Okay, into 3 plus 3. Correct. So basically he's saying, very good. So she's saying 3 into 1 plus 1 is 4. 5 into 2 plus 2 is 12. 7 into 3 plus 3 is 24. 9 into 4 plus 4 is 40. Okay. Very good observation, Ashi. But again, the same problem. When I go to 41, do you know what I should do into and what I should add? I have to figure out that. It's a bit of a pain, right? I can figure out, no problem there. So good start there. So I can figure out, right? It's 1, 2, 3. I just have to figure out 41 will come which term in that sequence. Maybe it's the 20th or maybe it's 19th. Thoda aage piche, around 20 it will be, right? Because every alternating, you're increasing by 2, but you're increasing only by 1, 2, 3, 4 in the other one. Correct? You're with me, Ashi? Okay. So basically, I'll know it'll be 41 into 20 plus 20 maybe, or I'm not sure. Is it into 19 or into 20 or 21? Oh, shak hai mere paas. Right? Instead, can we be independent? Any other pattern that connects 7, 24, and 25? Look at some other set. Let's say 11, 60, and 61. Observe them closely. If I give one more hint, all of you will pounce on me. Shall I?
Wait, I think the sum of 60 and 61 is 11 square.
Love you. Great. Yes. So 60 plus 61 is 11 square. 24 plus 25 is 7 square. 40 plus 41 is 9 square, and so on. So let's see. Sana, not Sana. Let's see. Yeah, fine. Sana, go ahead and complete this. What is 41 square, guys? Can someone tell me what 41 square quickly
This
is?
1681.
Very good. And how did you do that?
So I just knew it.
Okay, I really love your mental math. I would have done it as 40 plus 1 whole square, which is a plus b whole square, which is a square plus 2ab plus b square. Guys, there's no calculator allowed in AMC. You all have to crank up your mental math, right? 1681. Okay. Is that what you said, Jan? Right? You said 1681, right? Okay.
Yes,
by the way, it's an interesting one, right? 16 is also a perfect square. 81 is also a perfect square. The combination 1681 is also a perfect square. Okay. So yeah.
16 is 4
You can just
16 is louder. Whoever is talking, louder, please. Akshaj.
So you put 1 at the end, then the first digit you multiply it by 2, and then the first digit squared, so you get 1681.
Yeah, I'm just doing 40 plus 1 whole square, which is a plus b whole square. So it's a square plus 2ab plus b square. Are you with me, Akshaj?
Yeah.
Sure, right? Okay. I'm saying in this case, it's coincidentally that 16 also happens to be a perfect square. 81 also happens to be a perfect square. The full number 1681 also happens to be a perfect square. It's just a rare occasion like that. It's just a coincidence. Okay. Now back to Sana. Sana, you were going to complete what these two numbers should be in the triplet. We start off with 41.
This should be 840 and 841.
Exactly. What she did was she split 1681 into almost 2 equal halves. 840. 840.5 is when you divide by 2. But thoda aage piche. Left half, right half. So 840 and 841 are two consecutive numbers. And if you pull out your calculator, you can just check it quickly. Can you guys quickly, if you have a calculator on your desk, otherwise don't go searching for one. Anyone can do. Anyone has it handy? Can you just check and do the square root of this, and you should get 841. Can someone confirm, please? Fastest finger.
Yes, sir, it's correct.
It's coming, right? So nice, right? Otherwise, if you have to do 41 square and 840 square, it'll take a long time, which is why I said you can use a calculator. But if you knew this pattern and there is a problem, then there's, let's say, some side length with 41 and some right angle triangle, you can make an intelligent guess. Probably this is the triplet. Okay. That brings me to the next point. Know all your perfect squares, all your perfect cubes, powers of 2, powers of 3, till 1000 at the very least. Okay, so till 1000 you should know very least all of these. Why? Because no one is going to ask you what is I don't know, 23 square, right? Everyone can do it quickly. If you're asked 23 square, it'll take me 10 seconds to do it, maybe 15 if you're weak. That's all, right? But if you see a number like I don't know, let's say 841, are you able to recognize it's a special number? Saurabh, does 841 ring a bell to you? What is 841?
No, sir.
No, it does not ring a bell. Good. Neve, what is it? Go ahead, Neve. Your hand was up.
No, sir.
Oh, okay. I thought you were raising your hand. Arnav, does it ring a bell? 841 rings a bell? Okay. Gyan, what about you? No, okay.
No,
Ashi.
sir.
Ashi, go ahead. Yeah, very good. 29 square. Okay. So the reverse association is more important. If you ask 29 square, all of you can do it. But if you're asked, if you suddenly if 841 comes in some problem, Ashi will do it quicker because maybe there is a hint there based on 29 square. She recognizes it's 29 square. That'll give her a hint to the next step. Whereas the rest of you might be thinking as any other number like 847 or 922. It's just another 3-digit number. But the moment you recognize it's 841 is 29 square, that'll open up a new avenue. Okay, which is why I keep harping on it in all my classes, right? Know your perfect squares, know your perfect cubes. Okay. Powers of 2 are also very important, right? Another quick one. What is 1024? Rachit, what is 1024? Not out of turn, guys. Okay, I'll make sure everyone gets a chance. Don't worry. Rachit.
It's 2 to the power.
Okay, good that you're recognizing it's 2 power something. That's good. That's for a start.
2 to the
Yes.
power 10, sir.
2 power 10. Yes. Okay. Who was raising the hand? I didn't give a chance. Was it Arnav, you?
Yes, sir.
Okay, Arnav, 343 for you. What is 343?
So 343. It rings a bell, but I can't remember what it is.
Okay.
I think it's 17 square. I could be very wrong.
17 square should end in what digit? Arnav.
So I think 9.
9, right? So clearly it's not 17 square. Yes, Ashi. No, not Ashi. Sukrit, go ahead.
7 cubed.
7 cubed. Yes. What is, okay, who wants to go next? Challenge. Okay, Gyan's hand is up. Okay. Gyan, you have been good with remembering numbers, so I won't give you this chance. Let's see. Akshaj, I'll force it on you. Okay, you ready?
Yeah.
243.
3 raised to 5.
Excellent. Excellent. 3 raised to 5. Okay. Neve. 625.
So it's the square of I don't know, 24, 25.
It cannot be 24, right? 24 square has to end in 6. 25 square.
25.
25 square. Okay. All right. By the way, guys, you know how to find a square of a number ending in 5, right? So for example, if I ask you what is 75 square, Saurabh, do you know what is 75 square? Fatafat?
No, sir.
No. Okay, that's fine. Okay, Ashi, go ahead.
So what you do, you take 7 and 8.
Sorry, Ashi, just hold on just 1 second. Neve, you're saying something. Please go ahead. Sorry.
Can I answer?
Yeah, go ahead, Neve. Yeah.
Is it like 5, 6, 2, 5?
Correct. Sorry, Ashi, I'll come back to you. Don't worry. Yes. Can you expand why 5, 6, 2, 5, Neve?
So the 5 in 75 you square that, so it becomes 25, and then you multiply 7 to the next number, which is 8.
Yeah. Okay. So any number ending in 5, uska square, you put a 25 at the bottom, and then whatever number you have, multiply it with the next number. So 7 times 8, which is 56. You put that here. Okay, that becomes the product. Okay, Ashi, I think that's what you are going to say as well, right?
Yes.
But why is it? Ashi, do you know why that is the case? Or does anyone know why that's the case? Snigdha, do you know why? Okay. Sukrit, what about you?
I don't know.
Okay. All right. So let's derive why that's the case. Okay, so how do I represent a 2-digit number? So when I say or 3-digit number, doesn't matter, 563, you guys are not multiplying 5, 6, and 3, right? You're visualizing the 3-digit number 563, right? Whereas if I say A, B, C, you're thinking the product of A, B, and C. They are variables like A, B, and C, right? You're thinking as a product A, B, C. Whenever we use variables, that's the norm to think. ABC means the product ABC. I don't have to put multiplication sign. ABC is understood to be a product of ABC. But how do I differentiate the 3-digit number ABC versus the product ABC is by putting a bar on top of this. When I write a number, I don't have to put a bar. 563 is understood to be 563. No one is going to interpret it as 5 times 6 times 3. On the other hand, if I do mean 5 times 6 times 3, I should put like this or like this. Back in the days, in 3rd grade, we used to put like this. As we evolved, we started putting dots. Okay, but when I put variables, I don't even, either I can put dots, but even that is redundant. I just put ABC. But if I have to denote a 3-digit number with digits being single digits being A, B, and C, I put a bar on top of it. What is the meaning of this? This means the hundreds place I have A, the tens place I have B, in the ones place I have C, which means it's the number which is 100 times A plus 10 times B plus 1 times C. Does it make sense? Okay, so that's this number. Now, same thing applies for 2 digits. So let's take some 2-digit number. In fact, you'll see that it does not even have to be 2-digit number later after we finish this. Right? For now, let's take it simple, right? Let's say I have a 2-digit number represented as A5, for example, 75. Okay, now I want to square this. That's what I'm doing, right? So I'm trying to square it and arrive at that result. So what is the numerical value for this? A is in the tens place and 5 is this, 10A plus 5. Okay, in fact, let me call it not A, but I'll just call it M for just a small reason. You'll see, right? So let's say this is M5. So 10M plus 5. Okay, so if I square 10M plus 5, what do I get? So
10M squared plus 50M plus 5 squared.
Correct. 10M whole square, right? So 10M whole square, which is 100M square. Correct. Always say 10M whole square plus 2 into 10M into 5, right? A plus B whole square is A square plus 2AB plus B square, which is why I changed it from A to M, because when I recall A plus B whole square, it will confuse with this A, right? So I made it M. So A square, which is 100M square, plus 2AB. So 2 into 10M into 5, right? Plus 25. Let's simplify this. So this is 100M square plus 2 times 10 times 5 is 100M plus 25. So this is nothing but 100 times M square plus M plus 25. Now what is this? This is a number where 25 is the last. And then in the hundreds digit, this is the hundreds digit, this is the ones place, this is the tens place. In the hundreds place, I'm putting the number which is M square plus M, which is what I'm doing. The place value of M square plus M is 100 into M square plus M. The face value is just M square plus M. Does it make sense? Ashi, are you with me? Why this works now?
Yes.
Yeah. So in our example, M square plus M needed 2 digits, right? 7 times 8 was 56. So we put 56 in the hundreds place. But what do we mean by putting 56 in the hundreds place? Hundreds place can be only 1. That effectively means 100 could accommodate only 1, namely 6, and move the 50 to 1 step ahead, which is 56. So when we write, we don't feel all this, but that's what is happening under the covers. Is this clear to you, Sana? Clear to everyone? Saurabh, you're with me? All of you with me, right? Okay. Cool. So why did we start this discussion? This is based on the Pythagorean triplet, and then one thing led to another, and we went here. Okay, so 41, 840, 841. Now, it turns out that, okay, so first of all, what is my conclusion? I can start with any odd number. I can start with any odd number. I can square the odd number. I'll square the odd number and then divide it to almost 2 equal halves. So 2 consecutive numbers, right? I'll just say less than this. I'm just indicating what I mean, right? But these 2 are consecutive numbers. And I'm saying this is a triplet. Are you following my cryptic notation here? I'm starting with some odd number. I'm squaring that odd number and dividing it to almost 2 equal halves. And I'm saying this is a triplet. Okay, let's formalize this and see why it works. how do I represent an odd number? How do I represent an even number? First of all, I can represent an even number by saying 2 times n. If n is an integer, 2 times n is an even integer. Okay, that's easy. How do I represent an odd integer? 2n plus 1 or 2n minus 1. Yeah. So 2n plus 1 is an odd integer. 2n minus 1 is also an odd integer. Generally, people use 2n plus 1 for convenience. Okay, so let's say 2n plus 1 is the starting term. Now let's arrive at these two terms. Okay, so what are we doing? What is the process? We are squaring the odd number. So let's square 2n plus 1 and see. Just 1 second, I'll just push this here. So let's square 2n plus 1. So 2n plus 1 whole square is 2n square plus 2ab plus b square. Okay, so which is 4n square plus 4n plus 1. Now I have to divide into 2 equal parts, right? Almost 2 equal parts. So if I divide, actually it'll become 2n square plus 2n plus 0.5. So I won't take the 0.5. I'll take on either side without the 0.5, and with the extra 0.5, it becomes 2n square plus 2n plus 1. You're with me? All of you with me? Saurabh, you're with me? Saurabh, you're with me, right? You're frozen. Prachit, you're with me? Okay, cool. I'm saying this.
Yes, sir.
Okay.
Yes.
So okay, good. So 2n square plus 2n plus 1 is a triplet. That's the proposal. I've not proved it, but I'm saying this is a triplet. Let's verify if that's the case. Okay, all of you good so far? Akshad, you're with me? Okay, now let's verify if that's indeed the case. So how do I verify? So all I'm saying is, let's give them some smaller names, right? So let's say this is called A, this is called B, this is called C. I'm saying A square plus B square equal to C square. Or in other words, to verify, I have to check if A square plus B square equal to C square. Or another way to verify is if C square minus B square turns out to be A square. Same thing, right? So let's verify. Let's square C, let's square B, let's do the difference and see if we get A square. Okay, so I'm going to verify. So what is C square? What is B square? I want to do the difference of these squares. Okay, and we all know what is x square minus y square. It's x plus y times x minus y. Okay, so x plus y would be 2n square plus 2n plus 1 plus 2n square plus 2n. X minus y is just 1 because these are two consecutive numbers. The difference is just 1. But what is this? It's back to 4n square plus 4n plus 1, which, if you recall, was your 2n plus 1 whole square. If you recall this, when we did 2n plus 1 whole square, we did indeed got 4n square plus 4n plus 1. So we have verified that the difference of C square and B square was indeed A square, which means it's a Pythagorean triplet. Does this make sense, guys? All of you with me? Yeah, Neve, are you with me?
Yes.
Stigda, you're okay? Okay, cool. All right, let's stop here for today. Okay, and let's continue. So usual time is 2:30. Like I said, be prepared before 5 minutes before class. I'll open up Zoom so that we can start right on time. Today being the first class, few of you were running late, so I started a bit late. But let's be punctual. And also, like I said, have everything ready, right? Don't start searching for your work after we start class. Okay, there won't be too much homework in the first. Maybe I'll give some small homework. I'm not sure, but after 2 or 3 weeks into the program, after we have covered some of the basic stuff, I'll start giving homeworks. Okay, I'll send the recording. Do watch the recording also, right? Like I said, when you watch it second time, things will become more clear. Okay, bye. See you guys.
Bye.
Bye.
Bye, sir. Thank you.
Thanks.